Good morning to all of you. Now we continue with yesterday's session with the functions. Function still continues. We continue with the function. Yesterday we discussed about the actual parameters, formal parameters, where they are written, what is their use, what is their use. Now one thing is there. We should also know about the functions prototype and the signature. Now basically what is a function prototype and what is the signature? Now as I said yesterday, the function definition is there. The function definition, the first line of the function, which this is that in first line of the function definition is the function prototype. Generally this is the function prototype, but why do we need a function definition? What the use of a function definition? Now the function definition is actually an interface. It's an interface which is by looking at which the compiler acknowledges what it has to do, what are the requirement, because the function definition provides the return type. So function knows what it has to return. Function knows its name. Compiler knows the function's name. Then the signature is that in a parenthesis what you are writing, that parameters. So by the parameters it comes to know what parameter I need to use, what are the parameters requirement I have. So basically function prototype describes the function interface to the compiler by giving the details such as the number, the type of arguments, and the return type of the values. Basically it is termed as the first line of the function definition. You can note it down what I said right now. I am repeating it again. It describes the function's interface to the compiler by giving details such as the number, the type of arguments, and the type of return value. It is a first line of the function definition, and it tells the program about the type of the value which is returned by the function and the number of the arguments being used. Now what it helps to determine whether the function is invoked properly by comparing the number of arguments and number and type of the arguments. Basically it is very useful during the function overloading, when we overload the function. Overloading of a function means in a class when we can have many functions with the same name. Then how do the compiler comes to know that which function has to invoke? At that time it is very useful. At that time only it compares the number and the types of arguments which are present in the function definition, and whatever the value is passed is compared with it, or the parameters which you are passing in is compared with the number of the values, the number and the types of the parameters available. So what is a signature now? So basically it refers to the number and the types of arguments. Now, so function signature as well as the return type, they combine together to form a function prototype. So it's now clear what is a function prototype. The return type, then the function name is must, and then the signature. So it all together a function prototype, that we can say, or in other words we can say it as a function definition. This is the first line of the function. This is about the function and the function prototype. Then from the next session, in the next session we will have a function with a return value. Tomorrow I will upload another video where you will come across the idea about a return type value. What is a return type, how the function returns a value, what is the change in the function definition, how it has to be written. There will be a change in the, right now we are going with a void. There in the function definition we will have a return type like a primitive data types, either int, double, string, char, and so on, like that only. So now I will be explaining it on a pen and paper. and we will come across what is to be. You can note down the definition from there only. Thank you. Function prototype. It describes the function interface to the compiler by giving details such as the number and type of argument and the type of return value. It is the first line of the function definition that tells the program about the type of value returned by the type of the value returned by the function and the number and types of arguments. Now, what is a signature? It basically refers to the number and types of arguments. Now, function signature plus return type equals to function prototype. Now, a need of a function prototype, as I had stated earlier. What is the need of the prototype? The need of the prototype is it helps to determine whether the function is invoked means called properly by comparing the number and type of arguments. Alright, and this is about the function prototype and the function signature. Now I'm going to solve some program. Perfect, we have solved to print a to print the Fibonacci terms up to n terms, है ना. So we will print so web to create a function, void Fibbo, and here it is int to print all the Fibonacci terms, to print up the Fibonacci terms up to n terms. Is it? No. So again import java dot util dot asterisk class Fibonacci void Fibbo int n. So I need a int I to run a loop a, b and c. Let the c equals to 0, a equals to -1, b equals to 1, and so for I equals to 1, I less than equals to n, I plus plus, c equals to a plus b. So system dot out dot print c equals to b and b equals to c, curly braces close. So here you are printing it, the for closes and the void closes. Then void main, now scanner sc equals to new scanner system dot in. Now I require an int n1 which has to be passed to n. So system dot out dot print ln, enter the limit n1 equals to sc dot next int method, and now pass that Fibbo n1 main closes, class closes. Alright, this is so I equals to 1, I less than n, I plus plus, c equals to -1 plus 1, 0. So you will get the first 0 here, then I value change. Well, this is when I equals to 1 now. So a becomes a becomes 1 and b becomes 0. I equals to 2, then c equals to 1 plus 0 equals to 1. So first 0, then 1, then again a becomes 0, b becomes 1, I becomes 3, then c equals to 0 plus 1, 1, friends 1, and so on. Like this it will continue. Alright, now one more with a while loop. With a while loop we are going to write a program. Armstrong done, palindrome we have done, Cubo, Armstrong, now web to create web to create a function, web to create a function. create a function void magic int to check whether a given number is magic or not. To create a given number is magic or not. So import java.util.asterisk class abc void magic int n to check you require int n you require an you require r, you require s, and s is 0 while n is greater than 9, sum equals to 0 while n is not equals to 0, r equals to n mod 10, s equals to s plus r, n equals to n slash 10, then n equals to s, then n equals to s, curly braces, n equals to s, the outer while. This is an inner while closing here. Now outer while closing here. If n equals to 1, system dot out dot print ln magic, else system dot out dot print ln not, then you close the main. Now void main, here you run a scanner, sc equals to new scanner, and system dot in int n1 required, suplan system dot out dot println, enter the number, n equals to sc dot next, n1 equals to sc dot next, int method, and this n1 to be passed to the magic. So call the magic magic and pass n1, close the main and close the class. So hope so you are getting a correct view of it, clear view of it. This was the previous program. Now suppose I am receiving a value here with the n, I am receiving a value n here, any number, let it be 3. If suppose I 3, then 3 passes to n, so 3 is greater than 9, false. It comes to the condition here if directly. So it, if n1 is 3, then n3 gets copied to n. Now here it enters into the first while. The while here condition is checked, 3 is greater than 9, false. So it will not enter into the while. It comes straight down to if. It comes straight down to if, and there the condition n3 is equals to 1, false. It enters to the the else portion and prints there not. If you cannot remember, then I am giving you an example. This is basically a magic number is why it is n greater than 9, so that if the number is, after adding up the digits, if the number again is 2 digit, then we should continue with it unless and until we get a single digit number. Unless and until we get a single digit number, the process should continue. And if the single digit is 1, then only it's a magic, otherwise it's not a magic. For example, 55, you are taking a 55, then 55 is greater than 9, condition is true, it is a double digit number, so it continues. So 5 plus 5, it becomes 10. Again the 10 is checked. If 10 is again here greater than 9, true, so 1 plus 0 equals to 1. Now again it comes to the outer loop. Now 1 is greater than 9, false, so immediately it comes to the if condition here. 1 is equals to 1, true, so it's a magic. It is been checked like this. Hope so the things are getting clear to you. Thank you very much.